All right, so yeah, I'm going to talk about Terraform providers. My title is kind of misleading now because I'm primarily going to talk about how Terraform works, the role of providers, how they're written, and then I'm going to do a demo kind of showing how to write one. So I pushed the green button and nothing happened.
Push harder.
Push more? Oh, the big green one. The big green one. Okay. So hi, my name's Clint. I'm Catsby on GitHub. I joined HashiCorp in February 2015. I was hired to work on Terraform, with my main responsibility being the Amazon provider. It's quite large. It requires a dedicated engineer, and at this point, maybe even two, because it's grown considerably. My background is probably backend systems, CLI applications, APIs, stuff like that. I'm from Missouri. I work. Who said that? Yes. All right. So I'm from Missouri. I've worked remote for 6 years. It's great. Moving on. So yeah, Terraform providers. Terraform providers have grown quite a bit. When Terraform first launched, they had, I think, 4 providers and probably, I think, well, I forget how many resources. But now we've grown to a lot more. And today we're going to kind of get a tour of like how they're written. So just some data here. 0.6.3 came out in August 2015, so about this time last year. We had 16 providers. And you can see kind of how things have progressed. I don't have those versions kind of at any significant dates, but we started to grow and grow and grow. We had a big jump when we added Azure. Even more of a jump when we added a couple more in 6.15. And so now in the master branch, we've got 45 providers and 427 resources. So we've grown quite a bit. The little blue line is kind of misleading. The providers have grown almost fourfold, and the resources continue to go up and go up. When you have people like Amazon continuing to add new great things, you play catch up quite a bit. And thankfully, all of these things actually have acceptance tests, which we run all the time. Moving on. Let's see. So today, yeah, we're going to talk about what we call Terraform Core. We're going to talk about what providers are. Then I'm going to do a demo. And I had a section called There Be Dragons, where I was going to kind of talk about some of the pain points you end up encountering when you're implementing a provider. Working with cloud APIs can be a mixed bag sometimes, just due to their own scale. So I don't know that I'll actually get to that part, though, because in my run-throughs, the demo took longer. So, all right. So what is Terraform? Terraform is a tool for building, changing, and versioning infrastructure. It falls under the infrastructure as code blanket. Who here knows or has heard about Terraform? Lots of you. Who here uses Terraform? Equal amount. Who all has written and contributed code? Oh, you all are awesome. Who all has filed an issue? You are equally as awesome. Thank you very much. So yeah, we wanted to make a tool that can help operators manage their infrastructure safely. It's a single workflow that's supposed to bridge different provider areas. I tend to use provider and like service interchangeably. So things like Heroku, Amazon, Datadog, but most of you probably know that. We believe that changing these things should be handled by the tool, not the operator. The operator should just describe their desired state. And we let you do that through the common configuration language. That's based in HCL. Stands for HashiCorp Configuration Language. It's designed to be human readable and simple, but not specifically like offer, it's not like a DSL where you have control sequences, strictly speaking. It gives you interpolation and lets you bridge things together. This is an example. Most of you probably know this. Here we have just 2 resources, the cache cluster and a subnet group. We'll talk about some of the more specific things there. The configuration language is meant to be non-generic. We don't want these pieces to be interchangeable across different services because that kind of leads you into a lowest common denominator scenario. So they are all specific to each resource. Let's see. Okay, so the next part of Terraform you probably know is the graph. The DAG, the Directed Acyclic Graph. It's kind of the magic of Terraform in that it reads your configuration and builds this awesome graph showing people how things are going to be created and what order they're going to be created. And it helps Terraform determine like what order it needs to make things and what it can do in parallel. Yes. So again, looking at this slide, So we had the cache cluster. The cache cluster there references the subnet group, and it also references the security group. And you can see the subnet group up there references subnets. I don't show the security group just because this one is particularly large. And you end up with graphs like this. So you can see that the provider's at the bottom. It makes a VPC. It requires these subnets in order to make the subnet group, and then we have to make the security groups on the side in order to make the cache cluster. So it uses the configuration and the interpolations in there to construct this graph so it knows how and what order to do things. And you see, like, it helps, in this graph you can see the example of like parallelism in that those subnets can be created at the same time as the two security groups. That other security group, I don't know why I left it in there because it's apparently not used by anything. But you know, hey, maybe as an operator that's a good thing because you know, hey, I don't need that resource anymore. So, last but not least, Terraform is implemented with a plugin architecture, meaning we have Terraform core that handles basically the graph and other things, and then you can have providers which acts as a bridge between your tool and the various services that you're consuming, GCE, AWS. And we do that so that users can write their own providers rather easily. They just have to conform to a specific interface, and then Terraform can dynamically load up your plugin and execute it over RPC. So, stole this slide from a colleague. Thank you very much. So we see here we've got configuration state, graph, and a bunch of providers, right? So the configuration is supplied by you, the state is generated by Terraform. Terraform has this awesome graph tooling in the middle, and we have all these providers. That area there we refer to as Terraform core. It doesn't have to know about what providers do or how they do it. It just sees them as it can see them as black boxes and worry about how to manage them in a group instead of like worrying about how to deal with EC2 specifically. It can shelve that and let the provider worry about that. To be a provider, you only have to implement like a really simple interface. I've got a schema, which is the things that I need you to provide so that I can authenticate, similar things like that. And then it defines a list of the resources it contains. Like I have these resources so that when you read a configuration file and the configuration file says that I have a resource under my namespace, you can check it with what I've told you and see that it's there. Okay, yeah, so with this model, it allows you to bring your own providers to the table. You just have to implement the interface for the provider and the interface for the resource. Before Terraform 07, if you ever used that, when you downloaded it, you would have downloaded Terraform with about 40 plus other binaries alongside of it. We've since combined that into a single binary, but it still stays true to the plugin architecture there. It's combined them internally. All right, so that's Terraform core, but we're here to talk about Terraform providers. So providers act on the API interface of your services. They talk to the Amazon API, GCE. It can be infrastructure, it can be software as a service, like our friends Datadog. It can be platform as a service, like our friends Heroku and other people. Core handle, yeah, so the core then handles how we do diffing and all that stuff. That line was wrong. So a resource belongs to a provider, and a resource is anything that has a life cycle. Think an instance or an app or a DNS record. These things are created, they're updated, they're deleted. They adhere to their own CRUD setup like that. The provider then just has to know how to speak to the service that is exposing these, and then the core will actually just kind of give you instructions like create, update, delete. It'll go through there. Yeah, so Terraform, these resources just need to know how do I read my resource, how do I update it, all those things. Let's see, types. Okay, so a resource schema. So a resource, to be a resource, you have to implement the interface, which is defining the schema. I have these attributes, and then implementing at least the 4 methods of read, update, delete, create. Yeah, there you go. And so in your schema, your attributes have different things, like they have different types. They're strings, they're maps, they're ints. They have different behaviors. They're required. They need to be in the configuration. They're optional. You can bring that or not. They're force new, which is kind of a special one, meaning that if there's any change to that, we need to tell Terraform, or Terraform will know that instead of trying to update it, it'll just destroy it and make a new one. And then you have other things like computed, meaning a user won't bring that value, but we will read it and we will export it to the user so that it can see it. And these things can also have validations on your inputs, or they can have defaults, which are kind of tricky because using a default usually means you have to read the API's default, read their documentation, which is hit and miss because sometimes that changes and you don't really get an email. You do the best you can. See, I have 24 minutes left. So I've been talking for like 10. Wow. So I hit my demo a lot quicker than I wanted to, but hey, that's fine. So we're going to do a demo. And the demo is just, I'm going to write a provider on stage, and if I'm lucky, things will go well. So to do this, I created a service. It's just running on my laptop. It's called Compute as a Service, or CAS, as I will refer to it. It offers compute instances. It's going to make me very rich eventually. And we're going to write a provider. We're going to write a resource for it, and it's, well, I was going to have validation, but I haven't done that part. But we're going to do this because we're responsible developers. We're going to do this in a test-driven fashion. So, while I'm going to code the resource itself, there are some boilerplate type stuff that's kind of already there. I'll give you a tour of it, but it's not really the important parts. To make a provider, we're talking about to fit into the plugin architecture. As I mentioned, you need to implement a specific interface, and so you need to implement the interface. And you're creating your own binary here. As I mentioned before 0.7, you saw all the binaries with you when you downloaded. Now they're all internal, but you can make your own binary as long as it implements the interface and has the naming scheme of Terraform dash, and it is in a directory, either the directory you're running or a special directory that I won't touch on. It's documented though. Terraform will automatically load your plugin and execute it and communicate with it over the RFC. So that's where main.go is just creating the binary. Provider.go is actually implementing the provider interface. The config is how you would set up and configure the SDK. We'll touch on this. Real providers have much more complicated examples of these, but my demo one is very simple. And the SDK is typically provided by the service, in which case was me, which is kind of funny. So. Actual resource bits, the two parts we're going to have here are as resource compute and resource compute test. So looking at the actual structure of our plugin, we have Terraform CAS that matches the naming scheme Terraform expects. We have the main.go, which just makes the binary for us. And we have the CAS subfolder, which is provider, config, provider test we won't touch on, but the other two things are important. Let's see. And this was my little cue to go over to my laptop. Can you switch me, please? I will zoom in on that. So the hallmark of a Mitchell Hashimoto project is tests. Every project I've worked on of his has extensive test coverage. So naturally, Terraform has a very wonderful test suite. So let's look at the tests first because I modeled this demonstration to be test-driven. All right. So Terraform tests come in two parts. You have unit tests and you have acceptance tests. Acceptance tests actually create real resources. And we run these nightly on almost all the providers we have out there. We use Travis at the moment to do that, and so you can imagine not quite all 400 resources, but close to it are ran nightly to check things, and we have a lot of test coverage on each particular one. So the testing framework constructs this test case, and it allows us to provide steps. These two things aren't terribly important to discuss right now. So each step has a configuration. And what Terraform will do is it'll load that configuration and it'll apply it, and then it'll apply these series of checks. Now you can have multiple test steps in a single test, but for demonstration, we just have this single test step. So as I mentioned, we're going to go, I'll do these things really quick. So there's making the binary. You just import the Terraform plugin package and you call plugin.serve with your provider. That's very, very simple. The provider looks like this. It returns an object that implements the interface, which pretty much always just provider.schema there. We have our schema. We need an API key to talk to our service. And we have a resource map that says, hey, I have this resource. Resources have to be named in the namespace like that. It's provider_thing. And then you can see that in the configuration file I'll show you in a second. You also provide a function to configure it. Here, all we're doing is instantiating the client and giving it the API key. The config there is not that cool. It's a simple config, and it wraps our awesome SDK, which I will not bore you with. Actually, never mind. The next step is to bore you with it. I'm just showing this so you just understand what we're working with as I start to implement it. It's modeled off of the Amazon's SDK in that you have input things. And it has just very simple methods like create, get, update, delete. And it has these structs for inputs. So this is just the struct that we get from the API. It's got its ID, its name, its image size. We'll cover that in the resource definition. The input has these two attributes. I'll explain later why it only has those two. And so we cover just the very simple methods. All right, so now, where am I? I want to go here. Actually, I don't. I want to go here. So as I mentioned, everyone can read that, right? OK. So we're going to run this test. Actually, we're going to look at the thing first. So here we are implementing the resource interface. We return resource schema resource object. We've got our create, update, delete, read methods, and we have our schema. I'll cover the attributes here. We have an ID that is computed. That means when we talk to Cass, Cass is going to tell us what its unique ID is. We normally, in most intelligence systems, you probably don't supply an ID that much. It's great to have a unique ID. Our name attribute is just a string and is required. Our image attribute is supposed to be similar to like an AMI or something. It is also a string. It is required, and it's what's called force new, meaning that if we change the image, instead of trying to update it, we're just going to destroy it. The size is an optional parameter. We're going to say that's our disk size, and if you don't tell me what it is, I'm just going to say it's 5. And created at is, again, another optional one, which doesn't seem very significant, but I'll get to that in a bit. So our methods are empty, but we've satisfied the interface, so that's good. Let's run the test. TF something. There we go. So it's a normal Go test. You have to send the TF ACC1 flag or wrap it in something that does to tell Terraform that we are running acceptance tests. The idea there is that we want people to come and try our stuff out and try working with it and run tests, but you need to set a special flag in order for us to actually reach out and create resources because that's going to be on your dollar, assuming you're using your own credentials. So we're going to run that, and I'm giving it the run flag, and I'm saying run everything that matches this. We see we have when we type right, we have a couple tests, but they're all commented out at the moment. So TFA. OK, so run that test. It's going to fail. It should fail. It would be a disaster if it passed. All right. It failed because Terraform did not find the resource. It's not there. So the only thing you need to do to create a resource in state is set an ID. That's all you have to do. Now that's going to be in state. Check 1's probably, yeah. So check 1 did not pass, even though I gave it a state. And so that's going back to what we're doing here. I'll define now what these are. So these are simple methods that allow you in your provider to check values that have been stored into state. So Terraform, whenever you execute like a configuration, if you don't actually use a value in the configuration or update it from the API, it just accepts that as the state of the world and it'll put it in there. So if I never read the size or if I never read the name from a remote API and say, set this, it'll just take the configuration and put it into state. So Why it failed here, though, is because I have this little fancy guy, which I wasn't supposed to. I screwed up my steps. Anyway, what this guy does, he goes around and does an extra check. I actually call out to the service using I use the SDK to do it, and I query it by the ID, and then I check its attributes against the ones I have in state. This is a very common thing. You check a couple local things, and then you check that it actually does exist to try to catch weird issues where maybe you're not saving the state you want to. So here you see that we just checked the name, make sure it exists. And the error we saw was that it doesn't exist because it's never heard of that ID because I didn't send it anything. It doesn't make any sense for that to pass, right? So let's actually do this. The con object here is the client that you set in provider. So it's the wrapper of the SDK. So what I'm going to do is I'm going to do C here equals con.create compute, right? And I'm going to give it SDK.create compute input. Its name is from the configuration. And its image is from all right, so let's see, did it import? Okay, it imported the SDK, good. So we're supplying this stuff, we're getting that. The create compute gets back a compute instance, or a compute struct. So from here, we can just do d.setID is c.id. All right, now, let's do that again. Yay, it passed. I should say another thing, like normally to actually get the binary to use, you would run go build to generate it, which that will work here. That can be extra cycles though. The test framework will just kind of do that on the fly, which is pretty normal for testing, I believe. So go back to our test. What's the next thing we want to do? Next thing we'll show. All right. So here's an example of we're using multiple steps here. We're going to start, and Terraform's going to go through, and it's going to create the first version of this, which is cast compute. Name is that, image is that. They're just strings. And then we're going to update the image attribute. We're going to expect it to be image 456. Now, we're going to go ahead and run this to demonstrate something, even though we have no update method. And that's to hammer something home about that. This is going to pass. And so to recap why it passes is that in our implementation here in the schema, we've said that image is a force new attribute. So when Terraform tried to apply the change, it didn't ask the resource to do its update. It knew that, hey, this is something I can handle. I'm just going to destroy the original. I'm going to create a new one. So that's why this test passed, because it utilized the force new aspect. So it can be kind of misleading because you would almost expect that to fail, but we've leveraged a different part of Terraform to help us out there. So let's do a different part. Similar setup. We are going from the original configuration, and we're going to do what's called an in-place upgrade. So here we've changed the name to 456, kind of like what we did with image last time. No, go back. All right. Compute 123 to compute 124 or 456. We're going to run that, and that test is going to fail because we have no input. We have no update method. All right, name mismatch. So now we want to do our very simple update method. We're going to leverage a part of the resource provider and say if d.has change. Has the name changed? If it has, we're going to do update compute. And we're going to say it's for this ID. This is our name. Did something wrong. Did something right. All right, we'll try that again. I think this works. All right, it works. So we've now implemented a very simple update method. In our testing framework, we applied it the first time, we applied it the second time, Terraform found there's a diff, and so it called update, and it did that in line. It didn't need to recreate the object. All right, moving on to the next one. This is our, yes. So what this does, we're not going to check the other attributes because we've kind of beaten that horse to death. We're just going to go and we're going to use a different method that's just going to check that this value has been set. I don't know ahead of time what this value is going to be. You could jump through some hoops and query the API and check it that way, but I just want to know that it's been set at all. So I'm going to rerun all of those. OK, so we found that it does not work. It does not work because as a computed attribute, it's not in the configuration yet. It's not in the configuration at all. You wouldn't supply that, just like the ID. So what we need to do then is obviously implement this. Con.get compute. And then this one is not a well-formed SDK, it just accepts the string. You would also probably do a lot more delicate error handling and retries, but for the sake of demonstration, I'm not doing that. Name, let's see, c.name. So we're going to go ahead and read all of our properties. And the reason we want to read all of our properties here is because we want to utilize one of Terraform's core strengths and detect drift. I'm not going to demonstrate drift, but created at, and that's a string. Well, it's a time, so I need to convert it to a string. Well, you can run just commands like Terraform refresh, and that'll actually just look at your state file and grab all the new information and populate your state. It will not show you a plan or anything. So let's see. Does this pass now? I don't remember if there's another step for this one. OK. So there was another step for, oh yeah, that's right. So we only have one configuration file here. It goes through and it applies these things. But because I can't supply the created at, it only comes from the read, we're not actually ever calling the read method. So what a common pattern is for the create method to then go ahead and call the other methods here. So for now, we're going to do resource read, and we're going to pass in the meta. So we're going to say after we create, go ahead and read everything too. You'll see that almost, well, you'll see something similar in almost every resource provider. A notable thing is like security groups on, at least in Amazon, you can only create the group on create. You have to then authorize rules later. So we have to have that pattern of create it, and then immediately afterwards we're going to want to update it. All right, so that demonstrates that. We now create things, and then we go ahead and we read them. This is also helpful if for some reason a parameter was rejected, but the resource was still created. You can then read what the actual parameter is and find out that there's a difference, which is not ever fun having, but you can do that. So on to the next thing. How am I on time? Because I'm going very fast. Oh, we only have 6 minutes left. That's fine. OK, so update after create. Here we have a very simple one. But you see our size here is 10 gigabytes. And I mentioned earlier that this create input does not accept the size. That's kind of silly, but it demonstrates, similar to what we were just talking about, some things cannot be put in there on create. So we're going to run this as it is, and that last method should fail. We went through, we created it, we gave it the name and the image, and then we went through and read it. But we haven't done anything to call the update method. So instead of read here, what we're actually going to do is the more common thing is we're going to go directly from creating to updating. Updating then is going to do its thing, in which case we don't want to update just the name. We want to do has change size. It's going to read the configuration. Again, we accepted the configuration as it was because we didn't do anything with it earlier. And it had a default value of 5 gigabytes. It's going to recognize that there's a change there. And we're going to change the size. And then from update, if I ran it as it is, our previous test would then fail because we haven't connected the loop there. We need to now read it. And this is the most common kind of structure of any resource out there. You create it, you call update. If there's updates to be made, it does updates. And then in the end, it calls read before it's done, and it gets all of its values. So that now should pass. All of these tests could actually be done in a single test case, and they originally started that way, but I needed to break them out to be a little more granular in demonstrating some of these things. And causing a read in one would then populate the other, and I had a test passing when it shouldn't have. But so that's kind of the really, really quick, short talk of mine. There's a really, very simple provider. And I did that just basically to show you that providers can actually be really, really simple. And I've heard of lots of people who actually write their own for services that we don't quite have. Resources can get very complicated the more sophisticated they are and the more capabilities they have. But at its surface, providers are very simple, and Terraform Core handles a ton of work for you. That's all I have. I think I'm done early. I didn't implement the delete method, but it's called delete. And it mostly works. Yeah, that's all I have. Thank you for the time. Thank you for listening to me ramble for a little bit and write a little provider.